Good morning all. Myself Ramya, Assistant Professor, working in Department of ECE, Hindustan College of Engineering and Technology. I'm here to discuss about the subject digital image processing. Under digital image processing, just the introduction and the fundamental steps involved in digital image processing are discussed in this lecture. This picture shows the importance of the image rather than the words. When you explain these pictures through words, it will take more number of words to explain it to the other person. Instead, if we show the picture, it will give the more information to the other person, so that one picture is worth more than 10,000 words. Thus, image analysis plays the major role in human life. So, in this introduction, we are going to see what is the digital image and what is meant by digital image processing and the key stages involved in digital image processing, and finally the application areas involved in digital image processing. What is an image? Image refers to the two-dimensional function f of x comma y, where x and y are the spatial coordinates and f represents the gray level or brightness at the respective spatial coordinate. This is called as pixel, and the collection of all pixels together forms the image. And the image can be analog or digital. If suppose x, y and f all are continuous, then the image is called as analog image. If x, y and f all are discretized, then the image is called as digital image. Right? And the image can be analog for human viewing. It can be digital. The digital only if it is represented in matrix of pixels, it can be understandable by the computer system. So the brightness level is represented by the pixel here, which is the array of pixel. So it can be, image can be represented as the array of pixels starting from f of 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. Likewise, it can have m number of columns and n number of rows. And the another way is that when you want to represent the image, you have to consider the brightness level which you are involving in representing the image. If you involve only to gray level, which is black and white, the image, the minute details present in the image cannot be predictable by the doctor if it is a medical image. So that if you increase the number of gray levels to be represented for an image, if it is increased somewhat for 16 shades of gray levels, some details can be visualized, and if you increase the number of gray levels to 256 with 8 bits per pixel, you can able to get all the details present in the image. So, the image can be better analyzed based upon the gray levels used to represent the image and based upon the number of bits required to represent the pixel. It varies depending upon the application. So now, what is digital image processing? It is nothing but the processing operation performed on digital images by the computer. So, the image is given to the computer and the processing is done over there so as to make it to a better image for human perception or computer interpretation. So, to obtain a better image, various steps has to be undergone. Only after performing these all the steps, the image can be made to a better one for human perception or for computer interpretation. So, these are the steps given, and all the steps are monitored and controlled by the knowledge base. And from image acquisition to morphological processing, the output will be images, input will also be image. Whereas from segmentation to object recognition, output will be image attribute. Right? So, the first step is image acquisition. From the problem domain, image is acquired by means of the camera, which consists of sensors, array of sensors. So, when a light gets illuminated on the sensor, it will be sampled and quantized so as to get the digitized image. This digitized image is provided to the next category, which is image enhancement, because when you capture the image, obviously the image may contain various noises. It may be blur noise or Gaussian noise or atmospheric noise, turbulent noise or salt and pepper noise. Any type of noise may affect your image, so that image will not be visually appealable, so that it has to be enhanced further. For example, here the image is taken in a dim light condition. It is not visually better. So that to make it to be visually better, the second step comes into picture, which is image enhancement, which makes the image in a better form. But this image enhancement is a subjective process. It varies from application to application based on the perception. And the next step involved is image restoration. If suppose the image is affected by noise, those noise has to be removed and image has to be restored. For example, in this image, the image is affected by periodic noise. This noise has to be removed based on the mathematical knowledge about the periodic noise, and the image can be restored. So restoration is also trying to improve the appearance of the image, but it is based on objective model, which is mathematical model, whereas image enhancement is subjective process. The next step, which is optional, is color image processing. If suppose color image features provides more details for interpretation, color image processing might be involved so that the analysis may be made easier. Next is wavelets and multi-resolution processing. This wavelet and multi-resolution processing helps to represent the image in various degrees of resolution, and it is helpful for compression. The image compression is used to reduce the storage space required by the image and also the bandwidth required to transmit the image. For example, the image compression can be lossless or lossy. In medical cases, lossy compression is not preferable. So that if suppose the original image is taken, that may take 4 megabytes. So in order to reduce the storage required for that image, we are using the compression technique such that the image is reduced to 2 megabytes, but the quality is retained as such. But if you use lossy compression, the compression will be more. See, from 4 megabytes it has been reduced to 0.08 megabyte, but the quality will be less. So the lossless or lossy compression is determined based on the applications. Next step is morphological processing. Morphological processing is the processing which helps to analyze the image based on the morphological structure. Based on the shape of the image, if you are categorizing it, if you are interpreting it, then morphological processing is involved. For example, this fingerprint recognition varies from person to person, and the boundaries also gets differ. And the next step involved in image processing, digital image processing, is segmentation. Segmentation tries to divide the entire image into constituent parts or object and tries to extract only the necessary object. For example, in an image, if you want to identify the apple, I have to segment that apple, and various apples present in the image means various apples will be segmented. After segmentation, that has to be interpreted by the computer as an apple. For that, I need to represent and describe it in the form which is understandable by the computer. So the next step after segmentation is representation and description. In this representation and description, we are trying to represent the image in form of numbers. So here in representation, what we have done is the sampled image is represented in continuous chain of line segments, and for each and every line segments a number is allocated, and based upon this representation the features are described, which may be the described features may be area, perimeter, diameter, eccentricity. Likewise, various features are described, and based on the description the object is recognized. So the final step is object recognition. So object recognition is performed well only after completion of various steps. Not all the steps are necessary, but some steps are essential. Acquisition, enhancement, restoration, segmentation, representation and object recognition are essential, whereas color image, wavelets and multi-resolution, image compression and morphological varies according to the application. So now we have seen various types of steps involved in this digital image processing. So now we will find out what is the step required for enhancing, for modifying this image or for making this image better. In this image, brightness is more, so I have to introduce darkness here. So the step is image enhancement. And here this is the input image. I have to make the image into a better form. The image has been blurred, so blurring has to be removed. So the step involved here is deblurring. And this is the image of cheetah and zebra. This is the output image. What is the step involved such that the input image is converted to this one? So here this cheetah is segmented, zebra is segmented, so this is segmentation. So based upon these steps, this digital image processing is applicable in various areas. It might be used for target recognition, particularly in case of army, or in aerial photography, traffic monitoring, face detection, face recognition, and facial expression recognition, human activity recognition, in medical application to identify the tumors, mammography or x-rays, fractures, neural problems. For all the cases, image processing plays a major role, and it also is applicable in animation industry like morphing and film industry. These are the references referred for analyzing this steps in digital image processing. Thank you. Thank you all.